Hello, my name is Jared Taylor, and I'm the project lead of Project Group 15, TrussTech Engineering. We were contracted by the Colorado Department of Transportation to replace structure B27A. It is a bridge crossing an ephemeral waterway in Holyoke, Colorado. For this contract, TrussTech was tasked with creating a combined hydraulic and structures report outlining 3 structural alternatives and evaluating the hydraulic performance of our final chosen structure. This presentation will quickly outline the major findings of TrussTech's work.
Nestled within Phillips County, Colorado is the small town of Holyoke. It is in the northeastern corner of the state and is home to around 2,500 people. Within this small town lies structure B27A, a 2-lane wooden highway bridge constructed in 1937. The structure spans Frenchman Creek, an ephemeral waterway that has seen various flow rates throughout the years and proceeds to freeze and thaw. In addition to the deficiencies in the beams, erosion was detected in the wing walls of the structure. A century of seasonal flow under the structure has created various scour holes near the bridge piers and has led to further erosion.
Our 3 structural alternatives were a pre-stressed concrete girder bridge, a tied arch bridge, and finally a truss bridge. To determine a final alternative among the options, a list of criteria was created to identify the design that would best meet the needs of the community, including hydraulic impact, scour effects, ease of construction, speed of construction, weight capacity, cost of materials, and aesthetic design.
The hydraulic modeling process for this project was done using Aquaveo's SMS SRH2D program. CDOT provided us with LiDAR elevation data and a hydrologic study performed recently for us to develop 4 simulations for associated storm scenarios. These storm scenarios were for 10-year storms, 50-year storms, 100-year storms, and 500-year storms. As you can see from these images, the 10-year storm features minimal flooding, while the 500-year storm features gross flooding. At the 500-year storm, you can see the section at our structure B27A features flooding just north and east of the structure, an increase in flooding downstream as well. It's worth noting that the flooding downstream can potentially be due to backwater as the flow hits the edge of our mesh.
This section will look at the storm characteristics taken from the SMS/SRH2D model simulation. As one can see, each category, flow rate, max exit water surface, peak velocity, and peak depth, increase as the storm events get larger. It is important to note all of this data from the table was taken from the 30-minute time step.
The bridge deck will be supported by abutment caps on either end as well as 1 row of piers in the middle. These piers will be slightly offset to run in line with the approaching waterway. TrussTech's final structural design can be seen here. The proposed structure would span 165 feet over Frenchman Creek, as well as the bridge deck itself being a width of 43 feet to allow for 2 road lanes and 2 bike lanes as well. Scour analysis revealed a necessary scour design depth of 2.5.
AASHTO Type 2 girders comprised the largest portion of the total cost, coming in at nearly $630,000. The concrete deck was next, coming in at nearly $135,000. Various other components such as the asphalt deck, rails, pier caps, abutment caps, footings, and steel reinforcement made up the rest of the total cost. The total price for the bridge replacement is $943,425.
TrussTech greatly appreciates the opportunity to have worked on this project. Any further questions can be directed to our email, trusstechcsu@gmail.com. Thank you so much for watching.